to be here with you again in streaming about AWS WellArchitected. This is a very important episode. It's the first one about actually building AWS WellArchitected. Today we're going to dive into a bit more code than we've been doing so far, and I'm very glad to be doing this with you. I will be going step by step through a lot of CloudFormation. So if there is any problem with the audio or if the looks of anything you see, just let me know. I will be constantly monitoring the chat and seeing if everything's all right. I hope there is no issues today. I've checked everything and we are ready to dive into the WellArchitected. If you have any question or suggestion at all about the way you think this should go, please just type into Twitch chat and I will be right there with you. So just to make sure everybody knows where we are and what we are doing here, the whole subject of my series is this thing, the WellArchitected Framework. The WellArchitected Framework is very important because people believe that application architecture is a very special and unique and magic skill that people at Netflix or big companies have, and the goal of WellArchitected is showing how this is applicable for everyone and everybody can have a well-architected app. It will be different for everybody's context. What is well-architected for me may not be well-architected for you. And this makes it a bit hard to discuss application architectures at all. But here in the WellArchitecture document, you will see that it's all about the questions, and we've been through all the questions in previous episodes. For example, these are the questions that we will be covering today, the identity and access management questions. And you can see that the questions do not have answers here in the document. In the main document, you see only the questions, such as how are you protecting access of the AWS root account credentials, but you will only in the appendix there are some ideas for answering this question, but this may be different for everyone. So my idea to solve this problem and to help people implement WellArchitected is to actually provide some reference implementation. So in this repo, if you want a shortcut to it, I just registered this wellarchitected.io domain, and here you will find the templates and all the code that we are going through today. All right. So again, let me know if you have any issues at all around this. Okay. And what we'll be doing is covering from question to question how I built this, and if you have suggestions for making it more adequate to your environment and how things should go. So without further ado, let's start with the first one. So the first question in the AWS WellArchitected framework is, how are you protecting access to and use of the AWS root account credentials? So again, the root account is the account that you create when creating an AWS account with your email and credit card. And the important thing to protect here is why it is important to protect the root account is that the root account cannot be restricted in any way. If the root account is compromised, it can do anything on your account. It can delete users, it can change passwords, it can run miners or do anything at all. So we want to pay really, or even scam you, change your root password and scam you for money and things like this. So you don't really want to lose control of this root account, and this is how we are starting our talk today. So on this, I have this repo downloaded here, and I'll show you on Sublime so we can go through the code. On security, no root folder, you will see this no root.yaml, and this is the CloudFormation template that will notify you if anybody tries to use the root account. So what I'm doing here is using the CloudTrail service. So if you don't know CloudTrail, and let me show you what I'm talking about here. So on CloudTrail, this service will, when you enable CloudTrail, it will record and log every API call you do to AWS. So this will be tracked and monitored, so you can see when there is a root account, when there is a root access, you can filter that. Okay, so let me give you a better notion of how this works. I believe I have a diagram here to explain it. Let me pick it off from these diagrams that I have here. Just 1 second. So this is how it works. So first, CloudTrail is going to register API calls and log everything to CloudWatch Logs. Using a subscription filter, we are going to match everything that's from the root user, and when that matches, I'm going to trigger a Lambda function that's going to send a message to this cause of error SNS topic. So the idea here is that we should investigate everything that comes as root. So every time there is a root login, we should check it out and see, hey, is this legit? Like, it may be the case that you are changing your billing details, for example, or some operation that indeed requires root access, but most of the time you should not use root. You should use admin user, administrative user, or an IAM user instead of going to use instead of using the root account directly. So that's what we are going to do today. So here is how you do it. You can see here that I have some CloudFormation templates. I have decomposed it in several different CloudFormation templates. So the first step is to create the CloudTrail. So this audit trail, the CloudTrail trail here, is defined with the following properties: the CloudWatch log groups, ARN, the role allowing CloudTrail to write to CloudWatch logs, an S3 bucket to log things, and some more properties from CloudFormation. If this is your first time looking at a CloudFormation template, it may look a bit weird, but this is just a declaration of AWS services that you want to create, AWS resources that you want to manage. It could be instances, networks, anything at all that is managed by AWS. And the difference here is that you're doing it as code instead of just clicking the buttons or issuing the commands, right? This is a bit of a more structured way to manage things and to automatically create whole sets of resources. Okay, yeah. Hey Randall, we are going to have a lot of YAML here. I made us a favor and converted all the CloudFormation templates from JSON to YAML, so we can have it all here. And I'm going to show you guys some features of CloudFormation that are really important. You can see that when I enable my audit trail here on CloudTrail, I'm using this get@at function and this import value function. So when you see this bang thing on CloudFormation templates, this is called an intrinsic function. And the get@at function will go to the audit group resource and fetch the ARN from it. So the audit group here is defined right above. It's a log group, so it's AWS CloudWatch Logs group, and the audit role is just saying that that CloudTrail is allowed to assume a role that's going to allow the create log stream call to this log group. So this is how I bind things together. All right, you can use other functions as well. The sub function is just if you need to compose strings. This wasn't really necessary here, but I was playing with some other syntaxes, and well, there are a couple ways to do this. This is how I did it on this YAML. We're going to see several ways as we go along. But the important thing here that I would like to highlight is this import value function. Yeah, I did try mark the VS Code train. I just wish it zoomed properly. I tried to install a number of extensions to make it don't zoom the whole interface. I don't know why they made it like that, but as soon as I get it fixed, I will change to VS Code as just pretty much everybody else, and yeah, we're on it. And if you check this S3 code bucket name, it comes from this import value. It's just saying that it comes from another stack. So on this shared resources folder, I have some resources that are shared across many examples that I'm going to build. And in this case, it is the logs bucket YAML file. And here is just a S3 bucket and an S3 bucket policy. But in the end, you will see in the output section of this template that it outputs a reference to the audit bucket under the name logs bucket on this export. So this is how you can export values from one template, from one stack to be consumed by other stack, and they live separately. Like I can do whatever I'd like to the stack that references this bucket without impacting this bucket in specific. So for example, I can delete the log stream, I can delete my audit trail, and this will not delete the bucket. We are going to see when we talk about nested stacks that you can bind the life cycle with nested stacks, and this is called cross-stack references, where the life cycle of the stacks is independent, right? So check it out. Just so we can understand how this works, in the CloudFormation type reference, we're going to use a lot of that, so let me get that open. CloudFormation type reference. There is a very important, this is the most important thing for me when using CloudFormation. Let's pick the S3 bucket element resource. And in return values, you can see what it will return when you use a ref and what are the attributes available for get@. So here, when I do a ref on an S3 bucket, it will return the logical ID. This is not always the case. Sometimes it returns the ARN, sometimes it returns other things, but here is the name of the bucket. And you can use other functions such as get@, to retrieve the Amazon resource name, the domain name, the dual stack domain name, and other properties for this bucket. Under ref, you'll see the logical ID. So what this output is doing is exporting the name of this bucket as a reference that you can consume in other stacks under the name logs bucket. So instead of filling the logs bucket here in this audit trail, what I'm doing is just importing this value logs bucket. Okay, and this is the same idea goes on and on. For example, in this audit trail YAML, you'll see that I export the audit group, the name of the log group from CloudWatch Logs, so that I can create a Lambda function that does the same job. So here is how it works. I have a Lambda function that will be triggered when this log has an entry, and here is in this filter pattern property is where the magic happens. So when there is an user identity, when there is a log entry that matches this condition that says that the user identity is root and it's not an AWS service event, meaning that's a user triggered event under the root account, this will be triggered. This subscription filter will be triggered. It is here is importing the export from the log group, and it will trigger the Lambda function fn no root referenced by the Amazon resource name, and here we have the code. It will just do this. Here's the code. It will take the event data that is passed in the event property of this Lambda function. It's going to decode it. Log events from AWS logs are zipped and base 64 encoded. So I have to unzip and decode the message before sending it to the topic, and then I will send it to a topic that I'm naming cause of error topic or something like this. This is all that my Lambda function does. Read from the stream when it's triggered, and decoding the logs and forwarding to the topic. Let's take a look at the topic. So the topic here is just a topic with a queue. So the thing is, everybody's cause of error process is different, and you could send this to an application, you could send an email, you could do whatever you'd like with these errors. It's just important that you know they exist. And here I got this on an SQS queue, just so we can see the errors coming along and understanding how they work. So Randall, the filter there is not a regex, it's just an expression. I don't even know if there is a language. I think this is just a JavaScript, to be honest. Let's take a look at that again. So here on this subscription filter on the no root, it's just, I think the $sign means the current log entry, and this is just JSON. This is just digging into JSON. It's a custom language. I don't know. It's SQL-like, not exists. This kind of thing. I will have to check that out. Yeah. I don't know what is this. You know, let me know if you got this right. If you're just screen with me. But what language is this? Because it's not SQL. It's not JavaScript. It's not JSON. I don't know. It's probably something that we made up, but I'm gonna take a look at that. That's great question. Thanks. Oh, here. So this is the filter and pattern syntax. So let's take a look at that. So really, is there a spec for this? Yeah, this is the spec for it. More likely examples than a proper spec, but it's how we can filter and match log entries. Well, so as you can see, there's a lot. There's a lot you can do here, and to parse this. You can do a lot of events and capture whatever you'd like from the log events. Here it's just simply taking the root events with the root user. Very simple, but you can get pretty complicated. It's probably JQ or something reused, but we're not stating where that comes from. Yeah. Well, to be honest, I copied from another post, from a blog post. Let me show you guys where this is from. So this is the blog entry where I got it from. And you can see how to do it by hand. Here he did it by click and click. I just did the same thing by CloudFormation and reused his expressions. So thanks a lot, Chin and Man, for this. Check more. This AWS security blog is great. Check it out for more security information. All right. Well, so we got pretty much all we need. Another thing on the root, no root YAML, you will see that we have other references. For example, we need a bucket to store the code for the Lambda functions and things like this. So we are going to let's deploy some of these and create these CloudFormation stacks along with the code. Oh yeah, it looks like JQ, but I don't know exactly, my friend. Really, I don't know if it's pure JQ or some flavor of JQ that we develop. I wouldn't really know. And so let's start by creating this shared resources. We go from backwards dependency order and create everything we need. And to do this, I created shell scripts for everything, and those are going to use the CloudFormation CLI to create things. So I'm using the AWS CloudFormation deploy command, passing the stack name. That's the file with just getting the file with the same name, and using the CloudFormation deploy. And CloudFormation deploy will create a change set and create stack or update the stack if you need it. So you can think about it as the upsert for CloudFormation, because you could, let's take a look at the CLI and understand something about the stack sets. So when you create a CloudFormation template with deploy, it will create execute a change set. So if this is the first time you're running this, it's going to create everything from scratch. If it's not, it's going to determine the changes, and you can use the no execute flag to just show the changes that it would make on your behalf, or just send it and it would create the stack. So this would be the same as using create a stack or update stack. So if you would, you could update stack check if the stack, using list stacks, you can see if the stack exists, create the stack, or update the stack as is the case. But there's two problems with this. First, you gotta write this code yourself, and you have no idea what's changing. With the deploy command, you have a better understanding of what changes, and you need to write less code. So take a look at the deploy command if you can. And I'm going to bring up my command line interface on iTerm. Let me just increase the font here a bit and clear this. So I can show you guys the shared resources folder and create those resources. So let's start with that logs bucket. So this should create the logs bucket for us. Same thing for the other shared resources that we have. If we take a look at the CloudFormation console, here it's empty, and by now it's creating in progress, and soon we should have everything created. Meanwhile, if you guys have any question at all, just let me know. So yeah, it may take a while for this to complete. Success. And I will just go ahead and create our cause of error topic and queue just the same. So if you take a look at this script, it's pretty much the same thing. It's actually exactly the same because it takes the stack name from the file name, but in some cases it will be different. So for example, in the hosted zone, I add a parameter for the domain name. That's a parameter on the YAML file that you can pass to CloudFormation, saying whatever you'd like. And I like to capture those in, I didn't need to write a shell script here. I could just trigger the command, but I like to capture the parameters and everything I'm doing in shell script so everybody can do the same thing and adjust to their needs. I'm trying to build the YAML as the templates as flexible as possible, so you can run them on your accounts just by changing the parameters or things like this. So the cause of error topic is created. So we have already the topic and the bucket, and here on the stack, you can see the resources that it created and things like this. Okay, so we already have and now the code bucket. We need a bucket to store the code for those Lambda functions. So I'll create a code bucket just as I created the logs bucket. So we have the code bucket, the cause of error topic. We're not going to need a hosted zone for now. We have the logs bucket, and I have one for a TLS certificate, and we're not going to use this. This is for the application that we're going to build, but just take a look. It's pretty much the same thing. You can create TLS certificates, you can create hosted zones, you can create everything with CloudFormation. And same idea holds. You can output the resource names and resource references under exported IDs and reference on your code. But we're going to do something a bit different here for security. And let me show you guys a nice trick. Two nice tricks, actually. The first thing is, instead of creating one by one, as I just did here, you see that I created one code bucket, then created this, then create that. This can be a bit tedious and not very useful when you're having a more complex process. So there is a very special type of resource on CloudFormation, that's the CloudFormation Stack. So inside a CloudFormation Stack, you can create child stacks, right? So I have here this security stack, and the security stack is going to reference this admin user YAML. So this is the user that I'm creating to manage resources instead of root. So I'm creating this group, this IAM group called administrators, with the power user access policy that allows everything but creating other users. He can access all the services, but cannot create users himself. And an IAM user with a password passed as a parameter. No big deal here. The idea is that the admin user, the audit trail, and the no root function are going to be created atomically by CloudFormation. But there are a couple things here to notice. First is this depends on attribute. So with depends on, you can make sure that the audit trail is created before the function where it operates is created. And another thing that you will see is here this template URL. It references the template in my local machine, but CloudFormation cannot access my local machine. CloudFormation can only create S3 objects. So that's why in the security SH that I have here, I use this CloudFormation package command. So let's take a look at the CloudFormation package command on the CLI reference here. So CloudFormation has this package command, and it will recognize exactly these properties. So if you have the body location for a REST API, a code for Lambda function, code URI for a serverless function using AWS SAM, or a definition URI for a serverless API in SAM as well, or a source bundle for an Elastic Beanstalk application version, or in our case, the template URL for a stack reference. You can what CloudFormation package will do is upload this to S3 and replace the local file to an S3 location, right? So this is a CloudFormation package, quite useful when you are doing this inside, for example, your CI/CD pipeline, and you need to upload something to S3 and change your template properties. Instead of cutting and pasting and mingling with your template, you can just use this CloudFormation package command. Okay, so let's see how this is. So I will package the no root YAML, because if we check the no root YAML, it has this the same thing here on code. It references a local file that, well, I'm not I need to package. It will send to the bucket, and here there is another trick. How do I get this code bucket name? So check out this command here. I'm using the describe stack resources to get the code bucket stack, the stack that was created by the code bucket. And I'm looking for the stack resources which have the local resource ID equal code bucket, and getting the physical resource ID. So let's first execute this to show you guys how this works. If I just run this command, with the proper coding. It will show me what resources were created in this stack. So I'm getting this physical resource ID property. So I'm going through the stack resources property of this JSON, where the location resource ID equals code bucket. It's the only one, I could have more. And I'm getting this physical resource ID and converting it from JSON to text and outputting into this code bucket variable. So here you can see that this will return exactly the name of the bucket. So this is how you can pass information back and forth from shell scripts to CloudFormation, or query the state of things, and so on and so forth. And yes, my child Psyduck, if you have any questions, let me know. Because I'm going to package the no root. I'm going to package the security YAML. This will do that trick of sending to S3 and getting the results back, and then creating the stack that has child stacks within it. So let's do this and hope that everything is going to work. This is the time we pray, and so it's uploading to CloudFormation, changing the templates, and creating the stack. If we take a look here in the target folder that I have, you will see that the same template is here, but the URL and the references are changed to S3. Same thing for the no root thing, the no root template. It has a transformed template with a proper S3 bucket name and S3 key instead of my local file. And that's the magic of CloudFormation package. And on the CloudFormation console, we can see the security stack under creating progress, and the audit trail nested, and the admin user nested. Where is our no root function? Can anybody understand why we don't see the no root here yet? That's because the no root YAML depends on the audit trail. So here on our security YAML, you can see that the no root is going to wait for the audit trail to complete before it creates the no root function. Okay, and this is how it goes. And let's check. Let's just wait a bit for this. And this takes pretty much some 10 minutes to create, perhaps. So we have a problem here, a rollback in progress. Let's see what happened. Something went wrong. I don't know exactly what. Let's see. On events, the specified bucket does not exist. So, oh, I see. I probably did not create I created the zip before I created the bucket, I guess. Let me check that out. So we can always create, that's the good thing about having those shell scripts. We can always create things one by one. So I will delete this stack and let's try to do it one by one and see what happened here. Well, it should have been created. I just think I have an old version. So let me try to create things one by one. And so it's probably a bug in this no root here because I had it packaged in the zip before. So if you see the no root shell here, I do zip and package the thing, so it's probably the result from a prior step, and I probably should include that on the master shell, and that's probably why it didn't work. So let's try creating things individually. So sorry about that. I will fix this in the next version. Well, I don't know. For Sublime, surely not. I know that about this code complete. I know the console has it on the designer. The designer do have completion. I don't know any developer tool that has completion for CloudFormation. Sincerely, I just copy and paste from the properties, but from the CloudFormation documents. But that would help, yeah. And so on security, let's first create the admin user. And then, oh, that's great to know. Huh. I hope, let's see if Visual Studio Code will beat that. So this should create the admin user. But that's not our issue so far. I could probably create both in parallel. Let it wait for it to complete on background. How is background on Z shell? Well, it will create anyway. I don't need it. So let's go to the audit trail and let it create. Yeah, this can definitely take a while, and we will see that it takes some minutes for everything to activate properly and the logs start flowing, but soon we should see that coming along. And meanwhile, let's see if I can show you guys something more interesting than just waiting for CloudFormation to complete. Oh, this one was quick. So we have the audit trail, the admin user, and now let's see that, oops. Let's see that Lambda function. No root.sh. So this will zip my node modules, my Lambda function, upload it to S3, change my CloudFormation template, and deploy the whole thing. If we are lucky, this is going to work this time. On CloudWatch, we should probably see that we already have a trail there, so we can check out the resources on the trail group that is here. we can see the logs probably should be catching by now the information that we want from CloudTrail. And this is my root account for this, so not yet, but soon. Yay! So we already have everything completed. So when the logs start flowing, they should match that Lambda that expression. When they match, they will trigger the Lambda function, and this is quite important. I could use, for example, S3 for this. I could do the same thing with S3 events. But the good thing about the subscription filters is that it will only call the Lambda function when it needs, so you don't pay for the execution of extra Lambda functions for every log entry, just for the ones that matches your filters. So this is a bit cheaper. And well, we can see on the Lambda function itself if it ran already anytime. So on the monitoring, we can see that it was invoked once already. And so if it was invoked on the CloudWatch Logs, we should have some log entry. Yay! So we can see that I have a call from the user root, and that's exactly that filter again. So from the user identity when it's root, it's the same match that happened here on the filter. Where is that? Audit trail on the, yeah, here it is. So when the user identity type is root, so it's the user identity type, here's where it matches, okay? And when it matched, it invoked this Lambda function, and on the COE topic, we have the resource for our queue, and our queue is on SQS. It doesn't have a deep link, so I will go to the SQS console, and we should have some messages waiting for us there. So we have one message waiting for us already, and you can see that those take a while, but soon we should see more and more messages coming along as we use I'm using the root account of the console to trigger this. And on the view messages, I will start polling for them, and we can see the message here. So this console is not great for selecting things, so let me try this again. And I want to copy this to JSON linked, just so we can see it formatted. Here on the message is the actual JSON of the message content. And again, you could have an application doing this, you could have anything here. The thing is, this is probably not valid JSON, but you have the ID, the time, the message, the user identity, who did it, when. It's the same content as this. It's the same thing that you're seeing here, and you can see who did it, when it did, if it was with an MFA or not, and things like this. Awesome. Again, the link for the repo is WellArchitected.io, and this is just the first question. We are going to my goal here is to implement and give a reference implementation for every question of AWS WellArchitected on this repo. So this answers the first question, right? So everything that we've been talking so far is how to do this. How do you protect access and use of the root account? So we just did it using CloudTrail, CloudWatch Logs, subscription filters, Lambda, and SNS, right? And again, this is just a reference. Your own cause of error process could have an application or audit logs or anything. So yeah, this is just a repo that I'm building. And again, if you guys have, feel free to send pull requests or ideas, anything that you'd like. If you'd like to see, oh, I'd like a web app that does this differently or anything at all, just let me know. So the following, and here we see that the goal is to have no use of root, okay? And if you do have happen to use root eventually, make sure you protect it with a multi-factor authentication device. So one improvement that we could do here is check on this log message, and if the MFA authenticated is true, we could say it's okay and let it go because it was MFA, I trust MFA and it's okay, and just catch things that are MFA authenticated false, for example. Well, there are many ways to go around this, but the idea is don't use root, use the IAM user that we just created. So we have an IAM user there. If you're smart, you can even get his password and log into this account. It's a play account that will last only for this episode. So go for it while you can. I will soon delete this all. And the next question is, how are you defining roles and responsibilities to control human access to the management console and API? And the answer here is use IAM roles mostly under the least privilege concept. So give the administrators everything they need, of course, but not more than that. If we take a look at the IAM user that we just created, this admin user here, the managed policy that it runs is this power user access. So let's take a look at that in the IAM console. We should have this user, admin, and it's in this group, and it inherits from this group the power user access policy. That's exactly that ARN, and if we check the policy, it's going to show what it does. So it's allowing every service that is not IAM or organizations. So S3, SQS, RDS, EC2, everything is allowed except IAM and organizations. And I'm cherry picking create service link role, delete service link role, list roles, and describe organizations. So some actions that this power user may do. But the thing here is that it cannot create other users, create other groups, and so on and so forth. So this is pretty much what I defined as the least privilege for my admin. If you don't use other services, say for example you use only EC2 and RDS or MVPC, you could grant individuals their own services. And one thing that I didn't do here, and it's something that I want to improve, it's employee lifecycle managed. I really would like to know what do you guys use in your organizations for employee management. I hear a lot of people using LDAP and Microsoft Active Directory, but I don't know if it's the case for everyone. the question is, does your company have a centrally managed user directory for employees, so you can grant from the single place, from one place? So usually this is AD, and the idea here is that we should bind this record to AD, so when the employee is fired for any reason, you can revoke his privileges immediately, instead of letting him just linger and perhaps he have access afterwards and can do something bad. Or the same thing when employees are hired, they can just get in and access AWS when they have their register created. So this is identity federation, and it's something that I want to add to this reference implementation. I'm just thinking what would be the usual employee information source. I think it's AD, but I will check with some people first. Okay, let me know if you have any interest in this. This is also not so interesting for many cases. You can just use this admin user. And there is something else here. We are going towards full automation here. I want to make everything automated, and there is, as we go along and automate things, there is less and less need for human access to the console. So if we are good enough at this, when we get our reference implementation done, accessing the console would be an error. You shouldn't have to access the console. You can even fire a notification or beware if somebody accesses the console, because we're going to automate everything. And following that, the question is how you're limiting access to AWS resources. And here we have two by applications, scripts, third-party tools, and services. So we are using two kinds of credentials: static credentials for specific users and dynamic authentication for automated access. So let me show you what it means. The command line interface that I'm using here when I do this, I think there is a command called AWS IAM get user, and this should show who I am. So my username is Dalek, and so here on this Dalek user, I have the my security credentials. This is my access key ID, and the whole idea is that this is okay for administrator access and for running commands and using the CLI, but you don't want to embed this in code. You won't see credentials in any part of the code that I push to GitHub, because this would be a terrible idea. Of course, I don't want my credentials to end up anywhere. And if I put credentials in code, even property files, they become harder to rotate and change. So what we do instead is, for example, on that Lambda function that we just created, we create roles. So in the configuration here, you can see that it's bound to this FN role, and this role will say exactly what this function is allowed to do. So here it is allowed only to publish. It has the basic execution role. The basic execution role will let it write logs to CloudWatch Logs mostly, and also I'm granting SNS publish, so it can publish messages to the SNS topic, and the SNS topic on its turn have a policy that allows the SNS topic to send a message to an SQS queue. So using roles, you can authorize services to access one another on your behalf without explicitly sending credentials. So I would like to show you a bit more how this works, and let's play with the console and see how roles work. So I will create a role here, for example, that says that I will create a role for EC2, for example, saying that EC2 will be allowed to do something on my behalf, for example, S3 full access or S3 read-only access. So I will say that this EC2 instance will have read-only access to EC2, and now I will call this this role, for example, S3 reader. When I create this S3 reader role, now I can create instances bound to it. Let's do this. So on EC2, I will launch an instance, and just to demonstrate to you guys how temporary credentials work, I will move along with default credentials and select here that S3 reader IAM role, and just go with default settings for everything. Create a new key pair. Let's call it Twitch KP, and I hope I don't have that already. All right, so I'm the only one who can access this instance because I'm the only one who have this key. And in a few moments, we should be able to access this one. And so the key is on my downloads folder, and refreshing it, this should be pretty quick. On connect, we have the instructions, so I should change permissions on the key pair file, and I should be ready to access as soon as it boots. And the whole idea is you're going to see that as the instance is bound to the role, I don't need to explicitly say credentials and this is or authenticate. So I just what did I do wrong here? Perhaps it's not booted yet properly. Let's wait. I believe I typed something wrong on when it asked if I was going to authorize this, and let me remove the known hosts here and try it again. Let's type yes properly. Why it's not allowing? This is a new one. Twitch KP PM EC2 user. This should work. Let me try from the public IP. I don't know. EC2 user and this. Well, something's wrong here. I don't know what, but let's do this again. So I will terminate this and let's see if I can do this again. Sorry about this. Launch a new instance, Linux instance, configure this instance details. So yeah, I will pick the S3 reader role and let's double check everything, the tags, The security group is allowing SSH from everywhere. I will launch with a different key pair, so I will create a new key pair. Let's call it a brand new KP, because I may have an older version of this that was invalid, so I downloaded with a different name or anything. Maybe the case. Probably that was it. I probably created Twitch KP and downloaded that before as a test. So if that was it, this should be much better. Yeah. So thanks for the patience, guys. And this, I will show you how the whole IAM role and temporary credentials work. So this is quite important for a lot of scenarios. So let's just wait for it to be provisioned. And here it is. I can just go ahead and authorize the key anyway, the brand new KP. So this is done, and got it. It's up, and now this should work as soon as the instance boots, of course. And again, we're just going through the, this is not actually on the WellArchitected paper. I'm just showing you guys one aspect of this question, dynamic authentication for automated access, meaning how you can access resources without hard coding credentials. And this is probably the most important thing you can do for application security. So we're up and in, and if we type AWS S3 as a first command, you'll see that we have a list of the buckets in my account and my log buckets, my examples, and everything I did. And that is a bit weird because I didn't authenticate, I didn't do anything. How does it know that I'm Julio and this is my bucket? And we can even see that if I create bucket, so let's try make bucket something. I need an S3 URI, S3 bucket something. So I got access denied because my policy only allows read access to S3, so I can't create buckets. And the magic here is something called the instance metadata service. It's a magic URL. It's 169.254.169.254 if I remember correctly, and that's it. This is a versioned service, so I'll ask for latest and metadata. So I'm not deploying anything right now. I'm just showing how to manage credentials and how your application can call S3 without explicitly providing credentials. So on this metadata service, this is a local service. This will access the local hypervisor data where you can have everything in the running instance. For example, I could ask for the local IP or for any information such as the instance ID, for example, so and get the ID for this instance. And this is very useful for scripts, so you can fetch things from the running environment. But one thing that I would like to highlight is the IAM resource, and here you have the security credentials. So IAM security credentials. See, you have that S3 reader, the same role name that I bound this to, and here they are. So here are the credentials that were generated automatically for me. So you can see that there is an access key, a secret key, and a token. The token is a signature that will say until when this is valid, and anything that runs on this instance using the SDKs. So the AWS CLI is built on the Python SDK, also known as Boto, and Boto will fetch this for you automatically. So if you have anything running at all in this instance using the AWS SDKs for any language, they will fetch this automatically before executing the calls. And this is on EC2 is just to demonstrate how it works, but it's the very same thing for every other service. So when we declare roles, what's going to happen is the service is going to generate these temporary credentials and rotate them automatically, so you don't have to, and you can just run your commands and don't have to worry about rotating keys or passing credentials and things like this. Okay. So this is it for the question 3. How are you deploying resources? And this closes the identity and access management part of the AWS WellArchitected. So this is the content that I had for you today. We've been through Sec 1. That's how to protect access and use of root account credentials. So we detect from CloudWatch Logs and CloudTrail and trigger our Lambda function when it happens, and a Lambda function can do anything with this data. I'm just forwarding to an SNS topic, but you could insert in your system, send an email, notify the manager of the person that he or she shouldn't use root credentials and things like this. To define roles and responsibilities, we are trying, first of all, not to use human access to the management console and APIs and automating everything. But when we can, we have the admin user, granted the least privilege it needs using IAM roles. And ideally bound, the IAM user is federated to your employee record. So if your employee record ceases to exist, it won't be allowed by IAM automatically. And this is next on our implementation pipeline. And we are limiting automated access using temporary credentials. So human beings use static credentials, durable credentials, and applications and automations uses temporary credentials generated dynamically using roles. Okay, and this is how I coded identity and access management. Everything is in this GitHub repo on wellarchitected.io, all the CloudFormation templates that I've used today. On the next episode, we're going to continue implementing this and capturing and analyzing logs and enforcing network boundaries and protections and completing the security part, and then going through the whole of WellArchitected for reliability, such as how do we manage service limits or plan network topologies and things like this. The schedule is on AWS on the amazon.com/Twitch. So I will publish it will be after reInvent, because on November 27 through December 1, we're going to be streaming about the new launches and the new things on reInvent. If any of you guys will be on reInvent, ping us. It would be awesome to meet you in person, have a beer, and talk about the new announcements. And in the middle of December, I will schedule the next episode, and you're going to see it here on our schedule. And that's it for today's. Thank you guys for tuning in, and if you have any questions or anything at all, on julio.cloud you have my contacts and the GitHub repos, LinkedIn, Stack Overflow, Twitter, anything. Just ping me anytime. That's julio.cloud. Let me paste that here, and thanks. See you next time. Bye bye.